So the last couple lessons, we've gone through all of the different ways in which we get equations, which are equal on both sides. Today we're going to take our next step, and we're going to talk about inequalities. So an inequality is a mathematical sentence. My board is really acting up today. Inequality is a mathematical sentence that compares quantities that are not equal. Okay? So we're talking about the equal piece, that's our equations. Inequalities are not equal, but we are still doing a comparison of them. Okay? The terms that we use are stuff like less than, greater than, less than or equal to, greater than or equal to. Another way to think of it, less than, fewer than, same thing, right? Our symbol is, this is where we're talking about the alligators. No, where'd you put it? I don't see it either. I have it on tape. There's our box. Are you happy? Showing that we're still going. We had to show Mrs. McShann that the box is still there. So greater than is here, less than or equal to. Here's one you guys may not be as familiar with. Basically all I do is I do the less than and then I do half of an equal sign. Greater than or equal to, greater than sign with half of an equal sign. Okay? So when I see one line under it, what we're doing is we're adding one number to our solution set out of the entire universe of numbers. But that one number does make a big difference, especially as we're going to be graphing these. So for an example, normally when we're doing less than or equal to, we're going to be talking about variables. So we'll say something to the effect of x is less than 8. So in other words, any number less than 8 would now make this a true statement. So 7, is 7 less than 8? Yes. Is 0 less than 8? So all of those numbers are now true statements for this expression. Now inequalities, we're going to use the greater than. Now it's something, for example, x is greater than 100. So we have an infinite number, but here's one of the key ones. Is 100 greater than 100? No. So 100 would actually not be included in this data set. Is 101 greater than 100? Yes. Is 101,000 greater than 100? Yes. So that would be included. So any number over 100 would be included, but 100 itself is not. Now where we get the number included is once we start adding the less than. So for example, if I said x is less than or equal to 5, now is 5 less than or equal to 5? Yes. Yes, so 5 is now included. Where it's not with just the less than, it is with the equals. And we go the other way, we can say x greater than or equal to 24. So any number bigger than 24 would make this a true statement. Or equal to 24. Okay? So we can evaluate inequality with a given number for our variable and determine whether it is true or false. The way we determine true or false is after we have substituted the number, we do the math, and we read it, and we say, is it yes? If it's a yes, it's true. If it's a no, it's false. So for example, in this case, I'm going to say now that my variable x is 4. So I'll substitute that value in, and I'm going to check and say, does 4 plus 3, is that greater than 9? 4 plus 3 is 7. Is 7 greater than 9? No. So this is a false statement. Does that make sense? Anybody not understand that? Okay, let's try another one. Here we're going to say y is 6. So I'm going to substitute y in. 12 less than or equal to 18 minus 6. Is 12 less than or equal to 12? Yes. Yes, because that equal to is included, that is a true statement. If it had just said less than, is 12 less than 12? No. No, so then it would have been false. So what is it? What's the difference? That less than or equal to makes that one number now a true statement. Does that make sense, everybody? Okay, I want you to go ahead and do the next 4. See if you're able to do those and figure out if they are true or false. Okay, guys, let's look at these real quick. So I'm doing the first one. I'm substituting 8 in. Is 17 greater than or equal to 11 plus 8? Is 17 greater than or equal to 19? False. That is not true. Okay, here's our 9. Putting it over here, 9 plus 7 is greater than 15. No. Is 16 greater than 15? Yeah. There we go. True. Yes, it is. Putting 6 in for our variable. 22 less than or equal to 15 plus 6. Is 22 less than or equal to 21? What?
22 is less than 21?
Who said yes?
Definitely not me.
No, you didn't, Caden. Okay, 10. 10 minus 4 is less than 6. Is 6 less than 6? No. It is not. Again, had I had the less than or equal to, that would have been a true statement. That's why we need to pay attention to whether that extra line is in there or not. Any questions on those? Okay, our next step, we're actually going to show you how to graph these. This is actually a really big piece of this. You'll be doing this all the way through algebra. One of the first things we need to point out, and this is actually really important, you can actually ask my daughter. She's actually training right now to be a teacher, and she's doing her testing prep. And she wrote me last week, and she's like, Dad, why is this right and this one's not? And it was because she forgot the importance of the open or closed circle. If the answer is not part of the data set, we use an open circle, meaning it goes to this spot but doesn't include it. If that point is included in my data set, we close the circle because it's part of it. It's showing that this one belongs. So what do I mean by that? If I'm going to graph the inequality x is less than 5, I'm going to start my number line right around 5. So start your number line around the number that you're looking at, okay? This will make it easier for you and make sure that you've got enough space in the correct direction to actually graph your inequality. So it's going to start at 5. The first question I ask myself is 5 less than 5? No, if it's not, that means it's not part of my data set, right? So to show that, I use an open circle because the open means it's not part of it. Does that make sense?
Yes.
Open circle means it goes all the way to 5 but doesn't include 5. Okay? Now, here's your next step. You can pick a number on either side. I really don't care. If you want to go the same way every time, you can. If you want to just use your logic to double check it, you're free to do that. So I'm looking for a number less than 5. What I say is 4 less than 5?
Yeah.
So that means that number is included in my data set, correct?
Yeah.
So every number included in my data set, which is every number that is less than 5, I shade in that portion of the line. Now, do you guys want to see the difference between an A plus and an F? Okay, for those of you interested in the difference between an A plus and an F, this is F work, this is A plus work. What was the difference?
One didn't have an arrow, one didn't.
One I shaded the arrow, one I did not. If you don't shade the arrow in, you lose half credit. Because every number less than 3 is included in this. Technically, every number less than 5, but I said 3 because that's where my number line goes to. Okay? So this means that every number below 3 is included in my data set. If I don't include the arrow, then it's just saying it ends wherever my number line is. Make sense? So, do we need to shade the arrow?
Yes.
Is that important?
Yes.
Will you fail if you do not?
Yes. No.
Yes, you will. Okay. Let's look at another one. X greater than negative 8. So I'm going to start my number line at negative 8. Now, one big one to remember, because I'm starting on a negative number, is the numbers actually get, the integers get, absolute values get smaller as I go right.
Wow.
I wanted to say it properly since it's on tape. It was difficult. Because I haven't said it that way to the other classes. Now, here's again, our first question is, put the number that I'm comparing it to in for my variable. So is negative 8 greater than negative 8? No, so that means it's not included in my data set. So is my circle open or closed? Open. Open means it's not included. It goes to it but doesn't include it. Okay? Is negative 9 greater than negative 8?
No.
No, so it means it doesn't go to the left. Instead, it goes to the right. And if you want to verify that with yourself, try the next one up. Is negative 7 greater than negative 8? Yes. So I know it goes that way. This is making sense so far. Any questions? Okay, now here's your big difference. My symbol is now just changed, right? It's no longer just less than, it's less than or equal to. So I'm going to build my number line around negative 2. Okay? My first question, is negative 2 less than or equal to negative 2?
Yes.
Yes. So that means negative 2 is now included in my data set, right? Because I said yes, if that was true. To show that it's true and included in my data set, my plotting at negative 2 is going to include a closed circle. Then I can just check again. Is negative 3 less than or equal to negative 2?
Yes.
Yes, meaning my arrow goes that direction. If I had said no, I could try one on the other side. It would have been yes. And then I know that my arrow goes that way. Okay, our last one, we're going to do around 10. So I'll draw my number line around 10. Again, my first question, is 10 greater than or equal to 10?
Yes.
Yes, if I'm saying yes, that means that number is included. So I close the circle to show that that is part of my data set. Is 9 greater than or equal to 10?
No.
No, so it means it goes the other way. Is 11 greater than or equal to 10?
Yes.
So I know my arrow's going in the correct direction. Does this make sense? Any questions? Questions?
No question.
I'm sorry? There's also an arrow at the end of this number line. Okay? But, so if I don't include it, when I include the drawn line on that side to show that this is where it's going, that means I've not included the arrow. I have to show that it continues in that direction.
One of the things you previously said makes it impossible to answer truthfully. You said, does everybody understand? Does everybody have questions? I said yes to does everybody understand, and then you looked around for questions.
Yeah, because I've already asked does everybody understand a couple times. But I did throw an interesting dichotomy in there that makes it almost impossible to answer because one answer won't answer both.
Yeah.
But you could have said both answers simultaneously in the correct order, and then it would have made sense. Could have been yes, no.
Yes.
That would have been an appropriate response. Don't worry, Mr. Chan, it's logic. Guys, let's go over these answers real quick. So, on all of them, again, your first question is, put the number in for the variable and ask yourself if it's true. If it's true, it's closed. If it's false, it's open. So, is 9 greater than 9? No, so that means open. Is 10 greater than 9? Yes, means it goes that way. Should literally be that quick, guys. Is 8 less than or equal to 8? Yes, that means it's closed. Is 7 less than or equal to 8? Yes, it goes that direction. Is 11 less than 11? No, so that's open. It's not included. Is 10 less than 11? Since they only gave me one option on my numbers here. So that means all those and the arrow. Okay? Is 7 greater than or equal to 7? Yes, means it's closed. Is 6 greater than or equal to 7? No, means it goes the other way. Can you get it any easier, guys?
No.
Not really. Okay, go ahead and turn the page.
Wait, you could just give us the answer.
Okay, we're going to go through this concept again. We've already covered it when we talked about subtraction, property of equality, addition, property of equality. But it actually works with inequalities as well. So if I have 5 less than 9, is that true or false? True. 11 greater than 6, is that true or false? True. Now let's see what happens if I add 3 to each side. So if I add 3 to 5, and I add 3 to 9, then I have 8 less than 12. Is 8 less than 12? So that's still true, correct? On this side, if I add 3 to both sides, is 14 greater than 9? They're still true, right? Now another way to prove this is with our number line. I could say 8, 9, 10, 11, 12. Is 8 less than 12? How do I know that on my number line? Say it again, Solo. Because 8 is to the left of 12. Anything to the left is smaller or less. Anything to the right is larger or greater than, right? Please remember that for this test in 2 weeks, guys. That is like your pat answer for any of these comparison questions. Same here. I could have said 9, 10, 11, 12, 13, 14. Is 9 still, is 14 greater than 9? Is it further right on the number line? Yeah. So did it stay true? Yes. Now here's the other piece I want to see on this. How far apart are 11 and 6? Same as 14 and 9. Okay? Cool. On the other side, what we're going to do is look at what I do if there is a variable in there. The variable really doesn't matter, guys. The variable just makes it like what we've been doing for the last 2 class sessions. It's going to be the same process. I search my variable, draw my line through the inequality sign. What's the opposite of adding 5? Subtracting 5. Can I do it to just one side? No, I have to do it both sides. Okay? So 5 minus 5 is 0. 0 plus x is what? Y. What property?
The additive identity property of 0.
Well done, Devin. Additive identity property is 0. X plus 0 is x. Don't change your sign like I just did. Don't do that. Make sure you write the sign exactly like it is. Okay? So the less than sign comes straight down. What's 9 minus 5? 4. Okay? So we're building our own number line, so I'm going to put that in the middle. We'll go 4, 5, 6, 3, 2. Again, my first question is 4 less than 4?
No.
So is that included in my data set?
No.
So my circle is open. Is 3 less than 4? So that's the direction my arrow goes. That is how we solve an inequality and then graph it. Make sense? Let's see, any chance I can move that? Yes, we can. Can you move that for me? Sure. Okay, on this side, we're doing the same thing. Here's our variable. What's the opposite of subtracting 11? So I add 11 to both sides. That's our x. Keep my symbol exactly like it is. There are times you're going to change it. You'll learn that next year. We're not going to teach it this year. But for now, you're just going to rewrite it. 6 plus 11 is 17. So to graph it, 17 is in the middle. Is 17 greater than 17? No. So is my dot open or closed? Open, because that's not part of the solution set. Is 16 greater than 17? Nope, so it goes the other way. Is 18 greater than 17? Yep, so I know I did it right. Till it moved my arrow. I just make the arrow even bigger. Okay? Again, the difference between an A plus and an F is coming in that arrow at the end. Please don't mess it up. It's actually possible to lose more points than you can gain on these. Now, the good thing is, this is also true if I multiply or divide. So just as we learned the last couple lessons, if we follow our process, the opposite of multiplying by 4 is dividing by 4. 4 divided by 4 is Sean.
I said I'm sorry. 1.
Sean says 1 divided by 1 is 0.
With one whole class.
Okay, so 1 times x is?
X.
How do we know that?
Put the multiplicative identity property of 1.
Good. So that's just x. Again, redraw my sign. Less than 12 divided by 4 is? 3. She's leaving? Okay, so is 3 less than 3?
No.
No. So open circle. Is 2 less than 3? So that for all those at home, that was solo that doesn't think 2 is less than 3.
No, it was also even I didn't fill in that one.
Okay, our last one here for the example. What's the opposite of dividing by 8? Multiplying by 8. So that becomes 8 over 1. Those reduced away. I just have x on this side. Again, we draw my sign exactly like it is. 3 times 8 is 24. So my number line is going to go around 24. So have you already done this? Because you've written nothing down this entire time. Is 24 greater than 24?
No.
So open circle, is 25 greater than 24?
Yes.
And don't forget to color in the arrow. Okay, we're going to give you guys 5 minutes. Go ahead and solve all 6 and graph. Recording. Guys, please stop. Okay, I'm going to go through a little bit quicker because we're down to 12 minutes. All these are the same. Same as we've been doing for the last 2 classes. Circle your variable, draw your line. What's the opposite of adding 7? Okay, those are going away. So x, don't forget, copy your sign exactly. 10 minus 7 is 3. So I'm going to base my line diagram around 3. My first question, substitute that value in. Is 3 greater than or equal to 3?
Yes.
Yes. If I say yes, I do what for my dot? Close it, because that is part of the solution. If I said no, it's an open dot. Is 4 greater than or equal to 3?
Yes.
Yes, so that means my arrow is going this direction. Don't forget to close it, shade in the arrow at the end. Okay? Here's my variable. The opposite of subtracting 3 is? Adding 3. These go away. X is less than 12. So the middle of my line is going to be 12. Is 12 less than 12?
No.
No. Open circle. Is 11 less than 12?
Yes.
Yes, it's going that direction. Here's my variable. The opposite of adding 2, subtract 2. And less than or equal to 3. Is 3 less than or equal to 3?
Yes.
Yes. So I'm going to include that in my data set. Is 4 less than or equal to 3?
No.
No, so it's going the other direction. You want to check it? Is 2 less than or equal to 3?
Yes.
Yes. Are you guys seeing that this is relatively easy or not? Okay. Doesn't matter what my operation is, I'm always doing the inverse operation. So the inverse of multiplying is? Dividing. I'm going to divide both sides by 20. That becomes 1. 1 times x is x. Multiplicative identity property of 1. 80 divided by 20 is 4. So it's going to go around 4. Jayla, please stop talking and make sure you've got all this written down. Is 4 less than 4?
No.
No. So open circle. It's amazing what all this smartboard is capable of. Is 3 less than 4?
Yes.
Yes. So we're going this direction. Okay? The opposite of dividing by 6. Multiply by 6. These go away. X greater than or equal to 42. So it's going to go around the number 42. Is 42 greater than or equal to 42?
Yes.
Yes. Close dot. Is 43 greater than or equal to 42?
Yes.
So it's going to the right. And our last one. Divide by 7. So x is less than or equal to 8. 8?
Yes.
Is 8 less than or equal to 8?
Yes.
Close dot. 7 less than or equal to 8?
Yes.
So it's going in that direction. Sorry? It is. Any questions on that page? Okay, thumb meter, how did we do? You guys get them all right? All wrong? Okay.
I got the arrow.
So our next page, we're going to go. Unfortunately, we're down to just 7 minutes. So we're just going to rewrite the symbols up here to make sure you've got a quick reference, to make sure you write them correctly. But I'm not going to put words in for right now. What we do is practice writing inequalities, translating from English into math for these inequalities. One big one, we must define our variable. If you define your variable, it's going to help you understand what you're doing in these inequalities. The key to ask yourself as you read the problem and mark your text is, what is changing? That's my variable. If it's changing, it's a variable, okay? So you must be over 12 years old to ride go-karts. What's changing?
It's a very vague question.
No, not. Over 12 years old to ride go-karts. Are the go-karts changing?
No.
Okay, is the person changing?
No.
Has to be over 12 years old.
The ability to write books.
Yes. Okay. So what's changing is the age. So my X is age in years. Okay. Now to write your inequality, literally all you gotta do is write down your variable and the number that you've given. Good. And now I want to make sure that my inequality matches what it says. So it must be over 12 years old. So is 12 over 12? No. Is 11 over 12?
No.
So it can't be less than. Is 13 over 12? Yeah, so it must be greater than. Make sense? Let's try another one. A pony is less than 14 2/10 hands tall. So what's changing? What's my unit of measure? Does anybody deal with horses? Hands. Hands is actually a measure of unit. So X is height in hands. Okay? So I put my variable and my number, and then I find out what makes it equal, what makes it correct. If I put 14 and 2, is 14 and 2/10 less than 14 and 2/10?
No.
No. Is 10 less than 14 and 2/10?
Yes.
Yeah, so I need it to be a less than symbol. Our next one, you must be at least 16 years old to have a driver's license. What is it we're comparing? What's being changed? The age. So X is my age in years. Okay? So, again, I can put the variable and my number, because that's what I'm comparing. So, at least. So, it's 16, at least 16.
Yes.
So, I know it's going to include an equal to, because that number is included in my data set. Does that make sense to everybody? That's the first one that's actually works. I want to make sure that you understand that. Is 17 at least 16 years old?
Yes.
17 isn't at least 16?
Yes, it is.
It is? Okay. So 17 is greater than, and we said equal to is included. Okay? Once you've written it, if you're really questioning whether you're right or not, throw a couple numbers in there that are right around it to see if it makes sense. But here's one of the things that makes the translations difficult. Normally, if I said less than, that would be what? The less than symbol. But saying at least means it actually has to be bigger than that. So I'm actually using the greater than symbol.
In the same way it says.
No, so if it said no more than,
Yeah, no more than.
it would actually be less than. Okay? So you must be no less than 13 to play in the basketball league. So what is our variable? What are we looking at?
Age could be in the basketball.
Okay, age in years. And we know the X and 13 Is 13 no less than 13?
Yes.
Yeah, so equal to is included.
Less than.
Okay, less than. Is it less than or equal to?
No, greater than or equal to.
Okay. Greater than or equal to. Because is 12 no less than 13?
Yes.
12 is no less than 13?
No, it isn't.
No, so it can't be less than. It's got to be greater than.
No.
Okay, the quotient of x and 3 is less than or equal to 5. Okay, what is my variable?
X.
Which is
The value of x.
a number. Okay, the quotient of x and 3, what does that mean?
X times 3.
Quotient?
X divided by 3 is what it says.
No, it was not what you said, and I have the tape to prove it.
Nice try.
Is less than or equal to, so what's that symbol look like?
Less than or equal to.
Less than or equal to 5. Is this making sense, guys?
Yeah.
Okay, we have 2 minutes left.
That's enough.
Okay, excuse me. Your homework is class page. Okay? You don't have to do the ones behind those. If you can, if you want some extra practice on it. This is your homework. So the first part is doing the translation from English to math. The second part is solving and then representing it on a number line. You'll notice 13. That's 13. This one? Oh, thank you. It's less than. No, not that one. There is one that was wrong.
9.
It's 9. The quotient of x and 3 is less than. So add the word less than in there. Okay? All the rest of them should be good. We did throw some decimals in there just to make sure you couldn't do it all with mental math. But overall, they shouldn't be too bad. Any questions on what to do or what your homework is? Solo.
This page and this page.
No, just the last page. Just the last page of your homework. Is that this page? Oh, no. It is those last 2 pages, sorry.
Okay, so the one I...
It's going all the way from this into the into the problems down here.
Okay.
Okay? While you're practicing both.
Why did you